Hello juniors, and welcome back to programming. For this video, we're going to be going over logical operators and how they work in Python and how we actually use them with correct syntax. So what you're going to do is open up Eclipse. You're going to make a new logical operators project. So I've got one right here, but if you want to make one, you go File, New, PyDev project. Then you just put in logical operators. And then make sure your interpreter is configured, and then click Finished. I already have one, so I'm not going to make it. Then what you're going to do is go on to Canvas and download the logical outline.py, and you'll go along through this with me and complete it. You'll put it into your project, and you'll complete it as we go through this video. So I'm going to make a new PyDev module, and I'm just going to call mine practice. So let's first talk about the structure of these logical operators. So when we're working with them, the structure is just a Boolean plus the logical operator plus another Boolean. Now, as we know, we were looking at comparisons earlier, and comparisons can be simplified into Booleans. So we can say that this can be a Boolean or comparison because comparisons just become Booleans once they're broken down. So it's always, logical operator plus Boolean / comparison. So on one side, and remember you won't put these pluses, but you'll put the Boolean or comparison, a logical operator, and then a Boolean or comparison. And this whole thing will simplify to another, simplifies to another Boolean. So this is a way of adding comparisons together so that you can have these very large comparisons. So there's three different types of them that we have. There's and, or, and not. And actually, for not, it's only going to be a logical operator, which is the not, and the comparison operator. So it'll just be like this. But the and the or will have one on either side. So let's go through an example so that I can kind of explain this. 4 = 4 and 5 = 5. Whoops, that's the wrong one. Equals 5. That whole statement will come out to true. Now that's a complex statement, but the way and works is that if both the thing on the left and the thing on the right are true, then the whole statement will come out to be true. So what we do is we look at the left side, and that's 4 = 4, and we know that equals true. And then we look, so we can write that above it, true. And then we can look at the other side, 5 = 5. That also comes to true. So then we have two trues, and true comes out to be true. Now, if we did this a little bit differently, if we said 2 = 4 and 5 = 5. Now let's go through this one again. So 2 = 4. Well, that's false. 2 does not equal 4. Does 5 equal 5? Yep, that equals true because that stayed the same. So now, if we look at this, it's false and true. So the whole thing is going to return false because for and to turn true, both sides have to be true. And then obviously the last combination is a false and a false, and that will also turn out to be false because if there's two falses or one false, it's just going to be false. Now the next one we have is or. Now or works is that at least one side of the statement has to be true. So if we did our same example, 2 = 4 and 5 = 5, 2 = 4 is false and 5 = 5 is true. But as long as one side is true, then the whole, that should not be an and, that should be an or. as long as one side is true, the whole thing will come out to be true, because this is true, so it makes the whole thing true. Now, this can be kind of confusing when we're just talking about it with numbers, but when you think about it with complex statements, like when you're trying to check, is the username, let's just do an example. So we're checking, we'll make a string variable, and I'll just put a username as Michael, and then we'll do a password of one of my really old passwords. Now, if we're trying to make a program that checks this, we can have a variable, we'll just call it Boolean, and we say, is username equal Michael, and is password equal MJW11343. So then when we use like user input or something, they can input the username and password. And if you want to do perfect syntax, you'll do something like this, just because it makes it easier to read. Because you can see, okay, those two things, this first part is together and the second part is together. It just makes it a little bit easier. But we know that this whole thing, if we print out Boolean, okay, boop, run as, Python run, it's going to come out to being true, because username does equal Michael, and password, which equals MJW11343, also equals MJW11343. So the whole statement comes out to be true. So this can be helpful when you're doing large things. So maybe for this specific login, you only needed one to be right, and then it just lets you in. That's a very bad system, but it could happen, and that's how you would program it. You have the OR there. So now we're going to do the last one, which is not. Or actually, let's do a couple more examples of the OR. So we can do 2, and we can use some different comparison operators, so you can see how those would work with it. So if we have 2 is less than 3, or 5 is less than 10, that's going to return true, because both sides are true. 2 is less than 3 and 5 is less than 10. But what if we had one side that wasn't true? 4 is less than 3, or 5 is less than 10. Well, that still returns true, because 4 is less than 3, which returns false, because 4 is not less than 3. But 5 is less than 10, and that's a true, so then the whole statement becomes true. Because remember, only one of the two sides has to be true. So since this side was true, it worked out. Now if we do the last one, 4 is greater than 3. 4 is less than 3, or 3 is less than 2. Well, now both of these sides are false. So 4 is not less than 3, and 3 is not less than 2. So this comes out to be false, this comes out to be false, which means the whole thing is going to be false, because both sides are false. So that's all the different examples of using the OR logical operator. Now our final and last logical operator, remember we went through and that means that both sides have to be true for the whole statement to be true. Or, which means only one side has to be true. And then finally, we have not. So what not does is basically does the opposite of whatever it is. So if we know 3 equals 3, well, 3 equals 3, that comes out to be true. But the not flips it. So what's not true? Well, that's false. So then the whole statement comes out to be false. So let's try another one. We can say not 4 equals 5. Well, 4 does not equal 5. This statement comes out as true, or as false, because 4 does not equal 5. But the opposite of false is true, so then you just do true. Because not basically just flips it. It only has this one side, and it just does the opposite. So this is good if you're just looking for a specific program to not allow one number, like you don't want 0 to exist. So you can say as long as the user doesn't enter 0, then you're good. So let's talk about errors with logical operators. Remember that an error is a bug or something that is wrong in the program. And there's two types. We have syntax error, which means that there's a problem with the program's syntax, and logical error, which means that there's a problem with the program's logic. So for common syntax errors, it would be missing operator or comparison. So if you just put not, and you're missing the comparison. There's no comparison or Boolean there. Or let's say if you just, with or, you just missed one of these comparisons, or you missed the first one. That would be broken, and this would be a syntax error. Some logical errors would be using the wrong operator. So like for this example, if we're setting up a security system that has to have a person's username and password, we want them to get them both right. We don't want them to just know the username, then anyone could log into their account. So we want it to be and. So it would be a logical error if we forgot to make that an and, if we made it an or instead. Now the last thing I want to talk about is that all of these things, how I said you could use a Boolean or comparison, we've just been using comparisons, but remember, and you might want to practice these yourself, you can just do Booleans on either side. So if we do true and true, well, what does that come out to? That comes out to true. But if we do true and false, well, with and, both sides have to be true. So since one side is false, we're going to say the whole thing is false. Now if we do false and false, and just so that you can see this, you can actually put the print statement around it as well. So you can say print, and it'll tell you what the full thing is. Whoops. See, I left this error in there, so the program told me that it was wrong. Now if we keep going, it tells us that this whole thing is false, because false and false, well, that equals false. So I just want to remind you that you can use a Boolean or comparison, but with these logical operators, you'll normally be using these comparisons on either side because you want to add them together to make more complex things like security systems. So with this lesson that you've gone through with me, you should have filled out the whole outline. You should have gotten some examples of all the different things that need to be covered in the outline. And then you're just going to submit that on GitHub the same way that you always do, following the GitHub submission process. Then you're going to go back onto Canvas once you finish your outline, and you can do the logical operator drills. And there's the activity prompt where you can submit them following the GitHub submission process. And the drills, we can just take a quick look at them. Again, they're just like all the other ones. You're gonna get a task, and you're just gonna do that task. So you're gonna check if this string dog is equal to cat, and if this string mouse is equal to elephant, and store that whole thing in a variable. So it's gonna be one long thing like this, because we set b equals to whatever this produces, which is going to be true. So that's what you're going to do for all of this. Then once you get halfway through, you're going to go, and this is going to be like the last drills where you're evaluating it and figuring it out. So underneath each one, just like in the example, you're going to write true or false of what you think it is. So either, so we know that and has to have both sides to be true. So is 4 equal to 5? Well, that's false. And since one side is false, we already know the whole thing is false. So then we put false. So you're just going to go through and do the rest with all of these drills. Then once you complete that, submit in the activity prompt following the GitHub submission process. Then move on to the debug. It's going to be the same thing. You're going to get a couple of functions that are broken. You don't have to worry about any of the functions. And actually for this one, you just have one. So all you're going to do is look in these comparisons. But with these comparisons, they've got logical operators in them, and they're very complex. So you have to read what this function is supposed to do, and then you have this key here. So the CPU choice is a number between 1 and 3. The number corresponds to an answer. 1 is rock, 2 is scissors, 3 is paper. And so we're comparing the CPU's choice and the user's choice, because we're getting choice from the user every time. Then all you're going to do with this, there's 6 errors. It tells you right here at the top. You're going to find those 6 errors. Remember the ones that we talked about. There's logical and syntax errors. And then once you complete that, you go on to the activity prompt and submit it following the GitHub submission process. Again, if none of this made sense to you, there's all this supplemental stuff. There's more examples if you need more examples. There's the programming manual if you just want to see this written all out with a lot of examples. And then if you don't like the way I teach, there's W3 Schools and Tutorials Point that can give you a little bit of a different view on it. All right, tuners, if you have any questions, you can always reach out to us, but I will see you later.